Hi, everyone. Good morning, good evening, a few of you all. So, welcome to today's joint webinar by Array Networks and Stamus Networks, breaking through the encryption barrier for advanced network detection. I hope you're all able to see the presentation, right?
Yep, so we can see it.
So, today we will be going to cover network security imperatives with Stamus networks, so extending the network visibility with Array networks, its SSLO solution, a complete visibility and advanced threat detection using decryption, and there will be a demonstration walkthrough with additional use cases, and yeah, ending with the Q&A sessions at the end. So we'll keep it open at the end. So introducing our presenters for today, starting with Mr. Abhishek Srinivasan, who is the Director of Product Management at Array Networks. So speaking a few words about him. So he's a leader with a lot of passion, instrumental in driving product strategy and roadmap for all Array products worldwide, and setting up a strong technical team and driving new product investments. So he brings about 18 years of experience in cybersecurity, telecom, and networking, and bringing multi-million dollar products to market. So, having worked with Cisco, VMware, and Tata Communications in various roles, he's developed innate ability to understand the product market fit, and most of them have been in the Gartner Magic Quadrant for about 5+ years in a row. So moving on to our next presenter, that's Larry Hammond, who's advisory systems engineer from Stamus Networks. So where he helps prospects and new customers understand the technical value of companies' solutions through live demonstrations, proof of value installations, and extensive consultations. Larry is a frequent presenter and a public speaker. He has over 20 years of experience in cybersecurity, networking, and systems engineering, previously working for industry leaders RSA, Gigamon, BT, Motorola, and others. Yes, so here I would like to hand it over to Larry to take it forward.
All right, thank you very much. I'm excited to be able to speak with you today and talk about the exciting partnership that Stamus Networks and Array have together and how our products are going to be able to help customers solve very real problems in the real world. If we can go ahead and move to the next slide. The network is a great source of truth. So when you're thinking about how I can understand what's going on in my company, what's going on in my environment, particularly as we're all now so dependent on IT, so dependent on networks to reach our customers, to communicate as employees within a organization, we have to have the ability to see what's going on. And the network is a great source of truth because what happens between devices on the network can tell us a lot about what's going on in the environment. So we want to be able to understand what's going on from cloud perspectives, on-prem workflows. We want to be able to look at all of the things that are brought into a network. We have people bringing their own devices, the BYOD. We have machines that are brought in and set up by IT that are for direct use by work. We have networking equipment. We have IoT devices, cameras, door locks, even just different pieces of equipment that we use and depend on now. We also have OT whenever we get into the space of manufacturing, making things, controlling things. And there's a lot of these types of devices where we can't really throw an agent on there. We can't put something to monitor, Perhaps it's not sending logs in that we can review, but because the network is a source of truth, we can see the traffic going to and from those devices. And if we can unpack and understand what is in that network traffic, what's in those packets, it gives us visibility into what's going on and can give us critical insight into, is malware starting to take a hold of the system? Are we seeing ransomware or phishing attacks happening? And it also helps us understand, are there policy violations going on? Is there unauthorized activity? Do we have policy in place, let's say, that says the HR network should not talk to the engineering network or vice versa? And with network visibility, we're able to understand and determine that. If we could go to the next slide, please. So the Stamus security platform helps us do that because it does the deep packet inspection, so we understand exactly what's going on at the network level. And then we provide open and transparent detections. And what I mean by that is, I am only going to tell you things that you need to know. I'm going to tell you what you need to know, not that two devices are talking to each other and you should go check it out. Rather, I'm going to provide insight into why I am telling you those devices need to be investigated, what's going on there, so that the security team can quickly understand that traffic. That brings where it is actionable. Uh, the idea of being able to have very high fidelity alerting means that those alerts can be actionable and actions can be taken from the alerts themselves without worrying about taking down the network for false positives, let's say. We want to be able to give you detailed evidence. So we want to give the packet capture. We want to give the network flows that we've created so that you can understand, again, exactly what's going on at that network level. Stamus is built for large networks, having the ability to have high bandwidth probes that ingest the data, as well as being able to deploy multiple probes for a comprehensive visibility of the network. We also integrate with your other SOC tools. This allows, again, for those responses to go to a source system. We can send that to an IR ticketing system. We can have actions performed on our behalf through an EDR. And these integrations help the SOC analyst have a workflow that makes them more effective in their day job. Again, with that, we want to make sure that we're flexible in how we fit into your SOC so that your analysts are able to use the tool and not fight the tooling. And we're able to do this in on-prem, hybrid environments, public cloud, private cloud, to give that visibility. The next slide, please. When we're talking about our detections, we want to optimize those detections so that we're not using the wrong tool for the wrong job. If I am wanting to look for certain types of attacks, the easiest and best way to do that could be a signature. It could be that there needs to be algorithmic detections where learning takes place to see what's going on. Artificial intelligence, that machine learning, statistical anomalies, that might be the tool to find a particular type of hack. Also having discrete detection methods for very specific type of attacks that aren't signature based but are looking at the attacks discreetly, and being able to pull the most effective tool for each type of attack is going to enable your analysts to find that information much quicker and uh, help them more quickly get to a problem that is found on the network. Next slide, please. One way that we can look at uh, the information is we can see information in encrypted traffic that is going to allow us uh, to gain information. So we can create metadata based off of TLS information. We're able to use JAW4 fingerprints to understand and identify malware and C2 based on these fingerprints. We're able to look at uh, behavioral anomalies, beaconing to command and control networks, and using cipher suites, we're able to understand what level the encryption's at. Is it safe? Is it not safe? And with that help with that understanding from a policy perspective. Uh, and being able to use this encrypted traffic within the Stamus security platform, we're able to bring good insight. However, with array networks and their ability to decrypt this encrypted traffic within the environment, it gives us the ability to look at payloads as well, giving even further evidence to what's going on the network. So the next slide, please. So as it's building out, we're looking at the ability to place one of the Stamus network probes, say in a corporate office headquarters, a branch office, and be able to monitor the north-south and east-west traffic. The same for a data center or private cloud. Moving into the public cloud, and again, seeing those OT, IoT devices. Where each one of these probes are, this is a place where array networks can help feed that rich network data to the Stamus probe, allowing us to monitor easily the traffic and make sure the appropriate traffic is coming to the probe. The Stamus Central Server contains the UI and administration of these probes that allows an analyst to go in and dig through the data to find the rich metadata, to find the activity going on in the environment, and pull out that evidence for later use. That central server is very flexible in its deployment methodology, from cloud-based deployments to on-prem. Working with array networks, showing how I would like to pass it over to array networks to show how their technology is able to feed the Stamus probes to allow for this visibility.
Hey, thank you, Larry. Hey, thanks everyone for joining. So I'm pretty much excited to talk about how we combine with Stamus to bring the best of breed to the market, right? So before I go into further details of how we integrate and how we work, let's delve into what is it that Array Networks and its products bring to fore as far as the solution itself is concerned, right? Next slide, please. So, as Larry pointed out, right, as the networks have evolved, the attackers have also evolved, right? And 90% of the traffic now is completely encrypted, right? Just looking at the higher level visibility as what Stamus has been doing, we get one level of insight, but that's may not be good enough in order to prevent things from happening, right? So it's quite important that we handle the encrypted traffic, right? With the encrypted traffic, obviously the companies have now started investing in a lot of security products like NDR, right? And as that happens, you would see that there is a lot of latency that gets introduced as part of the process. There is the data visibility is to only to a certain level, and because it's encrypted. And then there is also performance that gets compromised in the whole activity, right? Because you are adding more probes or more equipments into the network. And as a result, the management of that also becomes quite complex, right? Given all these different challenges that we have, let's also look at how the arrays products do solve these problems, right? Next slide, please. Sure. So the first thing that I'm going to talk about is our arrays SSL intercept, right? This is the product that kind of dissects the whole, incoming encrypted packets and decrypt it and then send it across to wherever it needs to be sent. In this case, the Stamus probe, in order to make sure that they could look into it and make better decisions and better insights into what's happening in the network and prevent any kind of anomalous behavior, right? So this, because you're decrypting it once and then you could send it to any number of devices in the environment, basically you are offloading the SSL decryption from all these different devices. So what's the advantage is, first, their compute resources are used efficiently, right? And they can, and you could scale as much as you can, and we should still be able to get the traffic over to these set of devices. And at the same time, the investment and cost goes down significantly because you don't need to buy a higher end device which would also do decryption as far as these different vendors is concerned. So that's first part of what the arrays SSL intercept product brings to the table, right? So, and let's look at the next one, right? So, Shiv, maybe the next slide. Okay, the other product that can add more to what we just mentioned is the array NTB, the network traffic broker. The ability of this to orchestrate the traffic, either you could filter them based on different rule sets, layer 2 to layer 7, and just send the right traffic or the right amount of traffic to different products, right, that's are out there to analyze on them. Or if you want to do a deep packet inspection out there, or you want to block certain traffic from reaching, or in any case there is a failure of specific device, then being able to bypass and go through without any kind of disruption. All these different capabilities can be added on to the overall combination of the SSL intercept and the Stamus probes that you have in the network, right? So this gives more flexibility and control to how you want to manage these deployments. Next slide, please. So just to highlight what the NTP can bring in is multiple stuff, right? You can either aggregate or redistribute the packets to multiple, which means you can create copies, or you can combine inputs from multiple and aggregate them. You have an out-of-band load balancer kind of a behavior that can be achieved within this product. If you want to do packet engineering, right? You want to add something, some tags, or you want to actually do filtering of different, packets, deep inspection, you could do that. Um, there's advanced distribution, like we mentioned before, and in case if something is failing, you just want to bypass, you could have that control as part of this product. And then if you want to collect more data and send it across to our probes like Stamus, you could do that. And you could also have blocking capabilities based on indicators of compromise, right? Integrated with some threat intel there, right? All these different capabilities are present in this product, and which means you could use it any which way to serve this purpose of getting more visibility and control on the environment that is there, right? Next slide, please. Sure. So when we combine the two, right, the SSL intercept, which is able to efficiently decrypt and re-encrypt, and then with this particular network traffic broker, which can broker and control and make decisions based on different, characteristics that you want to set, and then you have the likes of uh, the probes coming into the picture. All of it put together makes the whole story a lot more coherent, and creates a big advantage for us compared to anyone out there in the market. Shiv, next slide, please. Okay, Larry, do you want to take on from here?
Yes, I do.
You're
Thank
talking
you.
about.
So, again, the idea of being able to bring uh, the network capability from Array, where they can give appropriate network data easily to the Stamus probe, and the ability to give that decrypted data to the Stamus probe uh, allows us great visibility um, in seeing what's going on in the network. So, the next slide, please. The great thing about encryption is, it gives us the ability to shop online. Without that, nobody's going to be sending their credit card over the wire to for shopping, etc. But when it comes to a SOC, it creates blind spots or performance issues, or criminals can use it to evade being seen and understanding exactly what they're doing. Um, so with this type of solution, we are able to keep that confidentiality and privacy, uh, as well as eliminate the blind spots and criminal evasion. And with Array, we also are able to address the performance issues. The next slide, please. And here we are looking at deployment. So um, we can see that we're able to decrypt across all TC ports up to 200 gigs, um, adjust the cipher suite selections, right? And making sure that trusted traffic is not decrypted. And then once that data is sent to the Stamus network probe, we are able to dissect that and give those high fidelity alerts. And then we're going to give that with the context of the network and what's going on. So by working together, we get a great view of the traffic, and we're able to look at specifically what we want to look at. So let's look at some benefits that we're going to be able to get from the combined solution. Next slide, please. Right. And so just reiterating what has been said before, we have deep visibility, right? We're not dependent on how a device is configured to see its network traffic. We're going to be able to uncover attack signals going over the network. We're going to be able to not just flood you with alerts, but bring up those high priority things, the things that need to be addressed. We want to empower our threat hunters. We want to empower those SOC analysts to be able to get to the information they need quickly, because their job is to tell the story of what's happening on the network when something bad happens, and to give them the tool to be able to do that, to tell that story with the evidence to back up their story, so that when it goes to upper management, the next level up, they can understand it and they can have confidence because all the evidence is there. Plus, it's going to allow early detection so that those alerts, the understanding of what's going on in the environment is accelerated. And then we can also, with the solution, maintain the integrity and compliance of that network. So let's move on to the next slide, please. And now we're going to get into a walkthrough of how these tools work together. The very first piece is going to be a shot of SSL basic details and statistics. Abhishek, if you want to describe this slide, please.
Right. So what we've essentially done is all the incoming packets that's been sent in has been has been decrypted on that particular the SSLI device that we have, right? And then all the connections have been accepted, as you can see on the right side on the screen, right? So there are RSA keys, 2048 RSA keys have been used. Obviously, right, it depends on what the SSL traffic is coming in or encrypted traffic is coming in. Every bit of encrypted traffic has been accepted. And then subsequently, we've been able to take those sessions and then also make sure that we give the decrypted packet over to the probe and then re-encrypt it and send it out. So essentially, when it reaches the box and when it leaves the box, it's always in encrypted form. And whatever Stamus just requires, that's specific data or information alone is passed on to the Stamus probe to take its decisions or take and look into the data packets and analyze it and come up with certain inputs, right? So that's what is shown here, right? Just to highlight the whole fact, right? Over to you, Valerie. Next slide, please. Shiv.
All right, so this is just a high-level overview of looking at the Stamus platform. On the left-hand side, we get a quick view of what's going on the network, what we've looked at, and the panel up above that is showing that we're going all the way down to being able to view printable characters that have gone over the network. So the next few slides, I want to walk through kind of what it would look like in the day of an analyst to quickly be able to interpret this data so that the organization can understand the security threats in their environment. Next slide, please. So in this slide, we are again showing that overview at the top, how much traffic has been ingested over a period of time, how many network transactions we're seeing, what type of devices we're seeing, the number of devices with services, things like, are we seeing domain controllers, DHCP servers, where an attack would be on the cyber kill chain, as well as our declarations of compromise. These are those high fidelity alerts that we talked about, as well as declaration of policy violation. These aren't declarations that we're going to inundate the SOC with. We're going to let the SOC know that these things are happening so that a company can adjust its security posture to help declarations of compromise go down. So that's going to be things like mismatched port protocol, passwords in clear text where that traffic hasn't been decrypted, those type of events. The box down, the lower box, is showing impacted assets. And it's showing in this particular case an asset, where that asset is in an attack on the cyber kill chain, what specific threats are on that asset, when it was first seen, when it was last seen. So that gives the threat hunter a lot of information very, very quickly. As we move on to the next slide, this is going to show the hunting capabilities. So each one of these boxes with the numbers is different types of metadata that is created by the Stamus probe as it's analyzing the network traffic. Any of these pieces of meta can be filtered on to allow an analyst to get a next level deeper very, very quickly. So as we move on to the next screen, this is looking at actually events. So we filtered on metadata, and now we're looking at particular events, and we're able to expand those events. The next slide, please. So that the analyst can understand what is going on. So in this particular case, I have highlighted certain pieces of metadata. The first being under the HTTP tab, the user agent string that is curl 3.7.1, the server type, which is basic HTTP using Python, and a tag and detection method metadata of PowerShell. These are all interesting things for an analyst to look at because it enables me to tell that story. So the first piece of the story from the user agent string tells me that this is not a user using a standard web browser. This is using a command line utility known as curl. The server is telling me it is not a standard web server that you would expect. Apache, Microsoft IIS, Nginx. This is a scripting language that has the ability to quickly set up a server. And then I see a tag of PowerShell. So in this case, I have an adversary that has set up a quick and dirty web server and has some access to a box to be able to use command line tools to download more tools, in this case using PowerShell. So I know where the information is coming from, I know where it's going to, and I have a rough idea of exactly what's going on. If we move to the next slide, we can now look at those printable payloads. And here I'm actually seeing what's going across the wire. And I am seeing calls that are writing information to memory addresses. If I go through the entire printable payload, I'm going to be able to understand exactly what this script is doing. Uh, Fortunately, the attacker has commented parts of this script, so I can see down in the response body that one of the functions here is specifically designed to overwrite the normal exit process of an exe so that the PowerShell will still be running in memory after that exe is closed. So now I have all of the data that I need to be able to explain that to management exactly what's going on, what the tools were, what the objectives were, how they were trying to gain those objectives. And I was able to do it very quickly through just a few clicks of the mouse. Also within the Stamus environment, I am able to have a copy of the PCAP and download it so I can send it in to that evidentiary file. So that is a quick walkthrough of how these two products can work together so that we can bring unparalleled visibility into what's going on in a corporate environment. Next slide, please. And Abhishek, I will hand it back over to you.
Thank you, Larry. Right. So this was just a tip of the iceberg, right? If you look at it, so we're just decrypting and then making sure that the Stamus gets visibility into those encrypted packets, and then you can see how much of information that Stamus can provide. That would help the administrator as well as the management to you know uh, detect and explain what's happening and then take actions, right? But that's, like I said, is tip of iceberg. So what are the other use cases that we could look to, right, achieve with this strip? Next slide, right? So this is another piece of information, right? Just think of it like you have network tabs across the network, right? And there are switches and routers and all of that, right, in the network. And if you really want to analyze across the network, right, using a single probe rather than having to deploy multiple of them, which could by itself be a challenge, right? So the NTB can be that aggregator which could aggregate all of these inputs into a single output, right? It can do the filtering of what traffic needs to be sent over to the Stamus probe and send exactly that, right? So that way, you are also ensuring that just beyond the decryption aspect of it, you also have this specific layer, which is also aggregating and giving the right amount of information to the probe to perform its action, right? So this would mean you can optimize the overall traffic, right? And high fidelity detections can happen, and at the same time you have looked at all the encrypted packets too, right, from all the different sources that you're looking at. Next slide, please, Shiv. Right, so this is yet another use case, right? You could also look at it from if you go in the previous slide, is that you could also look at it how you can solve your deployment, right? And how you can minimize when and where to deploy, how many number of probes to deploy, what kind of probe that you want to deploy to get this whole information sorted for you, right? So instead of getting a deployment done at different points, you could just do it at one place, right? It also minimizes the overall effort to maintain and manage it, right? So this is again a couple of use cases that we have touched upon. We could definitely look beyond these as scope, but I believe that we could start off with these for all of you, and then we could extend to new set of use cases as we go along. Shift. Next slide, please. Okay. So just to summarize, right, the entire gamut and what we're looking to do. First and foremost, we are ensuring that you have the highest level of visibility to the network and you are able to get all that information that's required to make decisions on any anomalous attacks or behaviors happening in the network, right? Um, Second, obviously the fact that the data is if it's encrypted, then there are inherent challenges of looking into it. So how can we ensure that invisibility is got to the SOC, right? Um, and handed over to them, right? So, and at the same time, just making sure that the privacy is still maintained, right? And all of this needs to happen in an accelerated mode, right? You just cannot compromise on the performance of the network. So the best of the breed technologies with arrays, SSLI plus NTP, which has patented technologies like speed core, bringing the aspect of fast decryption and re-encryption, while the NTP's visibility, the Stamus's visibility, make sure that you have the at most information that is required for you to move proceed further, right? Larry, would you like to add more?
Yeah, the ability to be able to see those payloads, like we talked about, where uh, they were setting up web servers and sending PowerShell across. The ability for that information to be sent decrypted gives great value. Um, the ability to have only the highest priority alerts sent is going to help the SOC feel less fatigued and be able to focus on what's really important. Um, Data sovereignty, again, being able to control what is encrypted or decrypted, as well as control where the data, the network data that's being analyzed live, gives you the ability to make sure that your data is where you want it and it stays there. Uh, the ability to accelerate that incident response by quickly identifying the blast radius of what's happened on the network, because you're able to see all of the network traffic in addition to what you may be getting from logs or endpoint today.
Yeah, sure. Next slide.
Shall we move to the next?
Okay, cool. Um, Next slide, please, Shiv. So
So
there are, yeah, go ahead, Larry. Go ahead.
I was just going to say we have produced white papers together to help explain this as well. And just want to help make sure that we're able to help you see those serious threats on your network and address them quickly. Something,
Yeah.
anything you'd like to add, Abhishek?
No, no, no. I mean, it's perfect, right? I did see a bunch of questions come in on the Q&A's panel, so I was just trying to address them. But I guess, yeah, let's go through this, and then we can get into the Q&A part of it, right? So, Shiv, next slide, please. So here's where you can find all the contents, right? The briefs, the videos, and the resources that you're looking for. As far as this particular solution is concerned, we have a working lab as well that's been set up to make this work. We will be also adding more use cases as we go along. But what we feel is like, hey, this is something that is going to benefit all the customers, and also make sure that we keep we keep the customers protected completely, right? That's what it is. Cool. Shiv, next slide, please. I guess it's Q&A next. So let me take those questions, right? So one of the questions that I see on the panel is, Encryption is that one of the reasons we like encryption. It keeps our private communication private. What assurance can you offer if we decrypt it that the data will not be compromised? That's a great question, Kim, right? I see Mark has a similar question, right? So the point is, obviously, when we decrypt, there is no copy of it or anything that's maintained, right? All we do is when you decrypt it, obviously there is uh, the arrays device is just acting like a forwarding proxy. So it's looking at the packet, decrypting it, and for the probe, whatever the relevant information is given back, and then it's re-encrypting and sending it outside, right? And these devices are well rugged and completely secure and certified, right? So as a result, no one can any tamper with it or get a look into the data, right? So none of that is anyway maintained into the repository, so it's all kept secure from a customer point of view. The second part of it is all of this can be deployed at customer's choice, right? They can deploy this within their own network, right? Need not be exposed to the public interfaces. So essentially, no one from outside can get into it, right? And you could create segments and rules, and of course, you could also create who can access and multi layers of authentications with multi factors that you can set up on these devices to ensure further that only those with privileged access are getting access to the machine to look at whatever minimal data that is captured out there. Hope that answers your question, Kim. I guess, Larry, the second question is for you.
All right. It says asking. There's a lot of discussion about NDR in the marketplace. There seems to be a lot of companies in the space. What makes Stamus unique? And I think there are several things that make Stamus unique. One, we want to provide as much data as we can. Um, as I show in the demo walkthrough, the ability to quickly get down right to that level, but we're not going to hold anything back. So in any of our detections as well, we're very transparent to that same level. So when a analyst is coming up and wants to understand why Stamus says you need to look at this, that underlying logic, that underlying reason is laid out for that analyst so that they don't have to spend time in their day trying to understand what that attack was. Uh, we also are very proud of our using different tools for different detections to make sure that we're not trying to just use one thing to address all of the different attacks that somebody can come up with, but use the particular technique that is best for identifying that type of attack. Uh, Also, time to value. We can very quickly be thrown on a network and start delivering um, value instantly, either from a just visibility, let me understand what's going on my network, to seeing attacks very quickly. We don't necessarily need a learning time to be able to identify problems on the network. We also are very simple in the way we do licensing. So it's just a very straightforward based on the size of the probe that's doing the ingestion, just to make that part of it much easier. Um, but that ability for the analyst to immediately get value, to immediately see that bad things are happening on the network is something that I really appreciate about our product.
Thank you. Thank you, Larry. Thank you, Abhishek.
Okay. Are there any more questions to take or?
Uh, Let me check if we have any questions.
Okay. I guess there's a question there for you, Larry. How Stammers deals with false positive detections.
So we have the ability for the analyst to quickly suppress that or take that over, such that it can quickly be removed from the set and not alerted on again. Um, so we're very it's a very easy process within the product to do that. And because we tell you exactly why the alert or the event fired, it's very easy to say, don't fire on that again because you have all of the variables, all of the things that went into that decision. So that makes it very easy to suppress.
Cool.
So, any other questions anyone has?
Cool. If looks like everybody is now thinking how to sell or how to position or how to get this going, right? So great. Um, Definitely, if anyone has any more questions, clarifications, you can refer to the recording. I'm sure that will get sent out after the meeting. All the resources would also get sent out. And in case you have more further questions, feel free to reach out to either of us so that we can clarify your questions and take it forward from there. Looking forward to making sure that the customers network are secured, made very visible, and at the same time have the best of performance that can be done, right? Thank you.
Thanks,
Thanks, Larry.
everyone.
Thanks,
Thanks for
everyone.
joining. Thank you, Larry. Thanks, Abhishek.